to find this derivative, so I'd start by distributing that 5. So it's 20 minus 5 cotangent x plus 25 cosecant x. Okay, and then when we find a derivative, we can do it term by term. The derivative of 20 is 0. The derivative of negative 5 cotangent of x, we need to know the derivative of cotangent. The derivative of cotangent is negative cosecant squared x. So anytime you're taking a derivative of cotangent of x, you can put negative cosecant squared x. And a negative times a negative is going to make a positive. So that's cosecant squared x. And then what I write here, that's a 25. That's we're taking a derivatives, so the derivative of cosecant is negative cotangent x cosecant x. So actually, instead of this plus sign, I'm going to change it to a minus, and the derivative of cosecant is negative cotangent x cosecant x. You might be wondering, why is that why does that happen? That's a common proof that students usually do in a calculus course. We usually start with saying, hey, the derivative of sine is cosine. Now go find the other 5 trig derivatives. And you can do that by rewriting them using the quotient rule sometimes. But at this point, we're assuming that we've seen the derivative of cosecant is negative cotangent x cosecant x. So there's our derivative. Determine all x from negative pi over 2 to pi over 2 for which the graph has horizontal tangents. Horizontal tangents occur when the derivative equals 0, so we're going to set this equal to 0. Oh, let me pause and check. I feel like I saw that WebAssign said things have to be in terms of sine and cosine for the derivative. Actually, it doesn't matter. I'm about to do it here. If you're having trouble with solving trig functions, it might take you a while before you get comfortable with them. But one thing I've shown students in the past is try putting things in terms of sine and cosine, because every trig function could be rewritten in terms of sine and cosine. Like cosecant squared, that's the same thing as 1 over sine squared, because cosecant is the reciprocal of sine. Sorry, I just caught myself. I copied down 2 a bunch of times. That's 25 here, so that's a big mistake on my part. Sorry about that. Cotangent is cosine over sine. That just comes from the fact that tangent is sine over cosine. Cotangent is just the reciprocal. And then cosecant is 1 over sine of x. Okay, so we do have common denominators. They're both going to have sine squared in the denominator. So let's multiply everything by sine squared of x, because we're trying to solve for x, and we can't solve if it's in the denominator. So if you multiply everything by sine squared x, then you've got 5 times 1 makes 5. And then this is sine squared x is getting canceled on the bottom here, so you got minus 25 cosine of x. So still trying to solve for x, so let's subtract that 5 from both sides. Divide both sides by negative 25. Okay, and then we want to use inverse cosine to get x by itself, because inverse cosine of cosine would cancel out. So this is one solution, okay, but there's another solution because we're asked to find all the solutions on this interval, right? And remember, with trig functions, sine of x equals something. This is an angle, right? And then this is a side ratio. If you have inverse cosine, then you've switched those roles of x and y, okay? Now this would be a side ratio, and this result is going to be an angle. So we just found out the angle that's going to make that equation be true. Okay, so that's our angle, and we could figure it out with a calculator too. So 1/5. Oops, wrong keyboard. Inverse cosine. So it's a positive 78.46 degrees. And so pi over 2, that's 90 degrees. 78 does fit within that range. It's supposed to be between negative pi over 2 and pi over 2. So 78 is fine, but we'll get the same triangle, in the same trig ratio if we were to draw it down here. And if you remember this mnemonic device, all students take calculus. Cosine is always positive in the fourth quadrant. And this is negative pi over 2 down here, right? So there's two solutions. There's this one, but then which is about 78 degrees, but then if we also write negative 78 degrees, negative inverse cosine of 1/5, that is also a solution. Okay, so this and this are both solutions to the equation within this interval that they gave us.